Hello students. So for those of you who are watching this video, you should be the students who have tested into Algebra 1. So if you're not in Algebra 1, please go back to my website and watch the other video. For those of you who are on Algebra 1, go ahead and either print the notes from my website or follow along with a blank piece of paper. Either way works for this lesson. All right, so today we are talking about solving equations with the variable on both sides, and I'm going to try to kind of use two screens. This is the notes from the book, or these are the notes from the book, and then these are just extra notes that I think you need to know. The notes that are down here is what you will need to show me during class. All right, so prior to today, you have only seen equations such as this. And you know that your first step in solving that is to get rid of this plus 4 by doing the opposite and subtracting 4. So we would subtract 4 from this side, and then that would bring us to 3x equals 11, and that's not a very pretty number, but either way we would still then from there we would divide by 3 to get rid of this 3 times x, and we would divide by 3 over here and we'd get some sort of fraction, or 11/3 as our final answer. So that is how we have seen it up to this point, but today we are going to be looking at it at equations where the variable is on both sides. And it sounds a little scary, but don't worry, we will go through it together. So before we move on to reading this big bulk of text, let me just give you an example down here on the notes again of an equation that has a variable on both sides. So let's go ahead and use my 3x plus 4 equals, and then we'll do 6x plus 8. So this is an example of an equation that has the variable on both sides. It has it here and it has it here. So in this paragraph up here, it says to solve an equation that has the variable on both sides, use the properties of equality to write an equivalent equation that has the variable on only one side, then solve. When you solve equations that contain grouping symbols, those are also known as parentheses, you may need to use the distributive property to remove the grouping symbols. Don't worry about the word grouping symbols, they're just using the fancy term for parentheses. Some equations may have no solution because there is no value of the variable that will result in a true equation. We'll get into those later, don't worry about reading the rest of this for right now. Okay, so here's our first example right here, example A. And I'm going to do it with you in the notes down here so that you can see how we do this first. So we have 3 parentheses x minus 2 parentheses equals 4x plus 5. All right, give me just a second. Okay, so as you see, these are the fancy grouping symbols, or we can just refer to them like we always do and call them parentheses. So we have to deal with this 3 on the outside first. So we have to rainbow this out, as I like to say. So we'll do 3 times x, which is 3x. And then we do the 3 times the negative 2. Don't forget that's a negative 2. So that would make this a negative 6 or a minus 6. And then don't forget that equal sign. This is carrying down that equal sign is one of the most common mistakes on these types of problems. So always carry down that equal sign. And then this side of the equation doesn't have any parentheses, so we can just keep it the same and we'll do 4x plus 5. Okay, so now we got rid of these grouping symbols. I think that's just the funniest term for them. And now we're stuck with an x on this side and an x on this side. So our first step is to determine one side that we're going to want the x's to be on. We can choose the left or we can choose the right. It doesn't matter. Every equation, you can change everything to the left side or everything to the right side. It doesn't matter. But we want to stick to one side. And for this one, I know that I'm going to be subtracting a group of x's from either this side or from this side. And if I have 3 x's here, I'm going to choose to subtract them on this to this side because that way I will stick with positive numbers. And let me show you what I mean. So right here I have a positive 3x. I have 3 x's just on this side, and I want them to only be on this side. So just like if this was a plus 3, I would subtract 3 to get to the other side. We're going to do the same thing, but we're going to group this whole 3x together. So we'll subtract 3x from this line. And then right over, oops, not like that. Hold on. We'll subtract 3x. And then under the 4x, we will also subtract 3x because we can only add and subtract like terms. We've always only been able to do that. And now we can do that in equations as well. So we subtracted 3x. These are gone. So on this side of the equation, all we have left is a negative 6 equals, now what's 4x take away 3x? What's this part right here? How many x's do we have left? We just have 1. So we have an 1x over here and then plus 5. Okay, now this part of the equation looks like what you've already been familiar with. We got all the x's on one side, and now we can just solve it like a normal problem. So to get rid of this plus 5 over here, we're going to subtract 5. And we'll do that right now. And we'll subtract it from both sides, so we actually need one over here too. Minus 5. So we have a negative 6 minus a 5, so negative 6 minus 5 is a negative 11 equals x. All right, so here's our solution to this problem that's up here, this one. Okay, and then what I would like you to do the first few times that you do these kinds of problems is check it. Sometimes with the one-sided equations, you can see it really easily if this answer is going to work, but I do want you to check it just to verify. The neat thing is that you can plug this x into any of the x's up here, and it should make the equation true. But just to be safe, we will try it in this first one. So this is me just plugging in the negative 11 answer that we got right here to this top line. So it's going to be 3 parentheses negative 11 minus 2. I'm sorry if you hear background noise. That's my cat kind of going insane right now. And then we're going to do the other side for x, which we already replaced x with a negative 11. So we're going to do it again here. And then a plus 5. And now we can just simplify this and solve. You can do distributive property here, or you can change this to and add the opposite and solve the inside parentheses first. So that would be negative 11 plus negative 2, which is negative 13, still in parentheses. And then we still have that 3 on the outside, don't forget. And then we have equals 4 times negative 11. Well, 4 times negative 11 is negative 44 plus 5. Negative 44 plus 5, and as well as 13, or negative 13 times 3. Negative 13 times 3 is negative 39. And we keep our equal sign, and negative 44 plus 5 is also negative 39. So at the end of your equations, when you have variables on both sides, these two numbers should always equal each other. Okay? So go ahead and let that sink in for a little bit. If you need to, you can look at these notes one more time. The last line that I'm not being able to squeeze in there is the negative, or x equals negative 11. It's down here at the bottom. So go ahead and take a minute and look at that if you need to, and pause the video now. All right, and if you want one more way to hear about the different ways to solve this problem just in someone else's words, these are the directions from the worksheet up here that I'm using, and you can take a moment, pause the video, and read through that if you'd like to. It's good to know that we got the right answer. Um, and then for your next problem, I'd like you to try on your own. Go ahead and try this one. It's number 1, the solve. This 4x plus 3 equals 5x plus 7. And then it's giving you this hint right here to subtract the 4x from each side. And the reason it's doing that is because we have to move either this 4x here to this side of the equation, or this 5x, or the 5x to this side of the equation. But think about it, if we moved the 5x to this side of the equation, we'd have to subtract 5x and subtract 5x, and then we'd be working with a negative x. And if at all possible, we try to avoid negative x's. Sometimes we'll have to deal with them, but as we're just learning right now, we'll just avoid them. So it's telling you the hint to subtract the 4x from this side and then subtract it from this side. So go ahead and try that one now and pause the video. All right, so this example is actually not on the worksheet, so I'll go ahead and do it right now. You had 4x plus 3 equals 5x plus 7, and the hint was to subtract the 4x from the 5x instead of the other way around. You would get the same answer if you did subtract the 5x, but you would have had to work with a few more negative numbers. So we subtract the 4x as one whole property, or one whole unit right there, and we take 5x and we subtract it from 4x here. And 4x minus 4x, well, that's just 0, so we can just pretend like we crossed that out, or you can actually cross it out in your paper. So we have a positive 3, or just a 3, left on this side. Keep your equal sign, equals. And then what's 5x take away 4x? Well, that's just 1x. So you have 3 equals x, and then don't forget about this plus 7. He doesn't want to be left out. So we have 3 equals something plus 7. So we can go ahead and do the next line, which is the opposite, or try and still get x by itself. We need to do the opposite of adding 7, which is subtracting 7. So we'll subtract 7 from both sides. First over here, and then over here. And you have 3 minus 7, which is negative 4, equals x. So if you got negative 4 equals x, you got this answer correct. Bonus points if you went back in and checked it. You can do 4 times negative 4 is negative 16, plus 3 is negative 13, and then 5 times negative 4 is negative 20, plus 7 is also negative 13. So those that solution works. All right, so to wrap this up, for your quiz, I'd like you to do numbers 3, 4, 5, 6, and 7. Don't worry about numbers 8 through 14. These involve fractions, and I'd like to show you those in class because my computer doesn't really have the ability to do fractions on here. So I'd like to work with you as an Algebra 1 group in class on tomorrow or on Tuesday, so that way that I can show you these a little bit more in depth. But these ones are all, oh, actually 5 has a fraction. So do 3, 4, 6, 7, and let's do 9 because that involves the distributive property. Please don't forget to distribute to both of these. Again, please feel free to rewatch this video, rewind, and watch, use any of this information up here or any of my notes down here below. And then keep these notes in the notes section of your binder. So go ahead and pause the video, do the quiz, which will be 3, 4, 6, 7, and 9. Oops, that's not 9, and 9. Well, you know where number 9 is. For some reason, it's not letting me highlight it. All right, so go ahead and do that now, and I will see you to work on homework in class tomorrow. Have a good night.